In today's lesson, we're going to be looking at sketching polynomials. So to sketch polynomials here, what we're going to first focus our attention on is finding the roots of the polynomial. So you notice here, polynomial is already factored here. This has roots at 0, so let's put a 0 there. It has a root at 2, so you're just estimating the approximate values of where these roots are located, then another root at -1. So to sketch this polynomial here, what we first want to look at is what is the end behaviors of the polynomial. As a reminder, to find the end behaviors of your polynomial, you must find the value of your leading coefficient. If I expand out my negative x squared and my x and expand that all out, we're going to have a leading coefficient equal to negative x to the power of 4. Therefore, as x gets infinitely large, our polynomial has an end behavior of negative infinity. So now we know my end behavior is down in this direction here, again tending towards negative infinity. How this works is once you find the position, so in this case here I know my polynomial has an end behavior of negative infinity, this polynomial is going to tend toward the root of 2. Now we have to decide whether the polynomial will cross the x-axis or whether we have a situation where the polynomial will sort of bounce off that root. To determine whether that happens, what you do is you look at the power on your root. So in this case here we see that for the root of 2, the power on this, although it's not marked, is a 1. And because the power is odd, what's going to happen is it's going to cross the root at 2. Then the polynomial will tend towards 0, and as we tend towards 0, the polynomial will then bounce off the root. And the reason for that is the power on the root is even for the root of 0. And then again, the polynomial will tend towards the root of -1, and because the power on that root is odd, it will then cross and continue on. So graphing this here, we're going to tend towards our root of 2. We're going to cross because you have an odd power, tend towards the root of 0, bounce off that value, and then again tend towards a root of -1 and cross. And this is a rough sketch of our polynomial. Let's try another. So for the next example, same idea. We want to find the value of the leading coefficient here. Well, we have here x cubed, x, which will be to the power of 2, and then an x, which will be to the power of 4. So putting this all together, the leading coefficient will be x to the power of 3 plus 2 plus 4, which gives us a leading coefficient of x to the power of 9. Labeling our roots here, we have a root at 0, a root at -1, and a root at 5. And now once again here, we can see here that as x gets infinitely large, our end behavior becomes positive infinity. So we're starting up here. We're going to tend towards the root of 5, and because it's even power, we're going to bounce off that root, tend towards the root of 0 because the power is odd. You can see here it's to the power of 3, it's going to cross, tend back towards the root of -1, and because the power is even, it's then going to bounce. And we have our sketch. Let's try another. For the next example here, same idea. This leading coefficient will be x to the power of 4, x, and x. So here we have a leading coefficient equal x to the power of 6. Again, this is positive. Identifying our roots here, we have a root at -1, a root at 1, and a root at 2. So as x gets infinitely large, we can see our end behavior will tend towards positive infinity. Notice here that we have a power that's odd, a power that's odd. So we're going to be, as we approach, let's label this for ourselves here. And you can see here I've labeled what's going on here. As I approach 2, we're going to cross. As I approach 1, we're going to cross. And then at -1, we're going to bounce. So we're starting up here at positive infinity. So we're going to tend towards our root. We're going to cross, tend towards our root, cross, tend towards our root, and bounce. And we have a rough sketch of our polynomial here. Let's take a look at another example. In our next example here, we want to find the leading coefficient. Again, the leading coefficient is going to be positive, and it's going to be x to the power of 2 plus 4 plus 10. So we're getting x to the power of 16. So again, draw your number line and find your roots. We have a root at -3, a root at -1, and a root at 2. As x gets infinitely large, we're starting up here at positive infinity. Now again, let's label what's going to happen as we approach our roots. So you'll notice here the powers are all even on this polynomial. So what's going to happen is as we approach our roots, we're going to bounce on each of these. So again, our end behavior is positive infinity. So we're going to tend towards our root of 2, and we're going to bounce. Go back up, tend towards our root of -1, bounce. And once again, go back up, tend towards our root of -3, and bounce again. So this is a rough sketch of our polynomial here. Again, the even powers mean that we'll bounce at each one of these roots. Let's take a look at another example. For the next example here, let's find the leading coefficient. The leading coefficient here is going to be, it'll be x cubed plus we have a power of 1 plus a power of 1 happening here, here, and here. And then again, because that minus sign in front, that's going to make this negative here. So our leading coefficient will be negative x to the power of 5. So again, draw your number line. We have a root at 0, another root at 5, watch out there, and another root at minus 1. So again, this is a root at 5. So you set what's in the brackets equal to 0. Now again, as we discover this here, as I let x get infinitely large, you can see here that the end behavior approaches negative infinity. And therefore, end behavior is down here. Let's label what's going to happen as we cross our roots. And again, I'm starting here at negative infinity. As I tend towards my root, we're going to cross, we're going to cross, we're going to cross. So you can see here that in this situation here, because all the powers on the roots were odd, we're crossing every time we approach that root, and we identified our end behavior as being negative infinity. So that gave us kind of our starting point, and then we can go ahead and graph our degree 5 polynomial. Let's look at another example. So in this example here, same idea. We want to find that leading coefficient. So let's go ahead and find the leading coefficient here. This will be x to the power of 2, power of 3, to the power of 4, to the power of 5, and then to the power of 6. And the leading coefficient will be negative x to the power of 6 here. So again, draw your number line and find your roots. We have a root at 0, another at 1, another at negative 2, another at negative 4, and then another root at 3. And let's label what's going to happen as we approach these roots. And you can see here the powers in all of these roots are odd with the exception of our root at 0. So we're crossing everywhere except for at 0, we're going to bounce. As x gets infinitely large here, again, as x tends towards positive infinity, we can see our end behavior is negative infinity. So we're going to go ahead and tend towards our root of 3 and cross, tend towards 1 and cross, tend towards 0 and bounce, cross and cross. So this would be a rough sketch of our polynomial of degree 6 here. That concludes today's lesson on sketching higher order polynomials. Thank you.